In the last year, I made almost 100 3D printable robots, all of which have tons of articulations. So today I want to show you how I go about creating joints, starting with a ball and socket. And because I model all of my robots in Plasticity, that is what we are going to use. This is an empty Plasticity scene. First thing I usually do is switch to a perspective camera because I just prefer the perspective camera. So we're gonna make a ball joint that is 10 millimeters. So I'm gonna select a sphere, I'm gonna place it in the center, I'm gonna hit tab, and because I've set my units to millimeters, I'm gonna write 10. So this is a 1 centimeter or 10 millimeters ball. I'm also gonna change the size of my grid to 0.05 millimeters. I found that this is great when working with tolerances. We are going to use a zero tolerance socket for this specific one, also because I'm going to use PETG to print it, so I know it's going to be flexible to a degree, but you might want to test out different tolerances eventually if you find that is too tight. So next thing I'm going to do is I'm going to create a center circle that's going to be a little bigger than the sphere. I found that at this size, to get a good tension in the socket, I want this to be about 17 millimeters. Again, depending on the material you use, you might want to change that. Then I'm going to extrude it, and I'm going to hit tab so it extrudes on both sides. I'm going to cover not all the sphere, but I would say something like this. I generally just try to eyeball it. I don't have a specific measurement, and you can definitely choose one if you want, but something like this is going to be okay. Then I'm going to go back to the top view. I'm going to make another part for this joint. I'm going to select the rectangle tool. I'm going to hit C to start from the center. And depending on how wide you're going to make this part, you are going to increase the tension in the joint. So I'm going to stay rather loose, perhaps something like this. I am going to push this. I'm going to hit 3 to select the face. I'm going to push it down. Then I'm going to select the bottom face, hit K, and match the bottom face. Now I'm going to select one of the faces or the whole object of the box here. I'm going to hit period, and I'm going to push the face back because I don't want it to interfere with the actual sphere. So as long as it's inside there, it should be good. Then I'm going to select, actually, let me remove this first. I'm going to select the box and this cylinder. I'm going to hit QQ, and I'm going to merge them. So now I have a single form. At this point, what I want to do is find a place where I can cut this so that it's open for the ball joint to enter. From the top view, I'm going to hit C on the line. I'm going to cut through this, and then I'm going to go back and select this one, select the line, and remove it. If you find that the base grid is annoying, you can also hide them like that. I generally do that. So I'm going to push this face in a little bit until I get this sort of form here. You can see it's kind of a spike over there and here as well. Because of how we set this up, the ball is now exactly in the center of this. So it should be easy to remove. You don't want to go past the midpoint of the sphere. So if you do this, it's not going to grab. You want to be just past the middle point, something like maybe 3/5, something like this, so that you have enough grab on the joint. Basically, when you start seeing this spiky form, it's not too spiky, something like this, it should be okay. If you exaggerate that, it's just going to snap. At least it's going to snap one of these edges. So now it's done. I'm going to select my socket part, and then Q, select the ball joint, and I want to hit T because I want to keep this ball. This will effectively Boolean the two forms together, but preserve the object that I used to basically cut. So I'm going to move it. Now you can examine the type of subtraction that you did. I think we might even want to go a little further, actually. Something like this. You'll see why in a second. So something like this is probably enough. It's pretty thick. I could have even made it maybe a little thinner. But I also need a way to print this ball here, because right now if I try to put this on a print bed, obviously it's going to slide off. So we have several options. We can, let's see what we can do to start with. We can make a cylinder here. I'm going to hit G and move this closer. I'm going to extrude it to make a, let's call it neck of this joint. I'm going to push it forward. And technically speaking, we could print it, orient it as such. If I do 9 degrees here, so we could technically print it like this, but I found that even if you add a support on the very bottom, the part of the neck here that connects to the ball, unless you make it very thick, is going to be fairly brittle because of the layer lines. So it's probably going to snap. What I recommend is to start thinking about the print orientation from this face. So if you notice, I did already orient this in a way that can be printed. And this orientation here for ball joints, or even if you use something similar for hinges, is the only one that is going to last very long. Because when you print it, the layer lines are going to be across this instead of being like so. And so it's not going to open up as much as it could have. So keep this in mind. If you want your ball joints to last longer, you have to print the socket like this. So what I'm going to do for the ball is instead, I'm going to duplicate this one. And then I want to remove some extra here. I don't really care about all of that. So I'm going to add something like this. I'm going to hit G. I'm going to move it a little closer. And now you're going to notice that if I don't print this vertically, there is part of the ball which overflows this box. This is obviously a problem. So we could take the ball, hit C to cut, and select this face to cut a chunk off of it. Effectively, we have made at least the bottom part. We could do the same thing of the top part, obviously. We have made this now the same size of the socket. The problem is, if you rotate this like so, this is not going to be very tight. So what I ended up doing, at least for my designs, was having 2 different sizes for the balls and the sockets. So the balls would have a slightly taller support, something like this, and then I could safely remove a chunk of that. I would generally only do it on one side, so if you cannot tolerate asymmetrical, again, do it on both. But I found that it's okay to keep it asymmetrical. This way, just by removing a little chunk from that, we can effectively print this thing, if I hit QQ, as it is, and have it not unstick from the bed when printing. The tension is pretty much the same, so even though it's not technically speaking uniform, I found that in any case it holds enough for my mechanical toys. Last thing I want to do here is duplicate this because I want to keep a safe copy, and then I'm going to select all of the edges of this thing. I'm going to hit B to bevel or fillet, and then C to chamfer, and I'm going to hit 0.4. So this gives it a nice chamfer that's not going to make it too spiky and prevents those extra spikes that were around here from snapping when you insert the ball. If you want, you can do the same thing on here. I'm actually going to probably do it. It's not really necessary, but if you're making toys for kids, it's really a good idea to make those edges a little less pointy to avoid cutting yourself. So BC 0.4, there you go. Now we can export it, and in Plasticity it's really easy actually. So just select the part that you want to export, go to export. I also bound it to Control-Shift-E. So I'm gonna save it as an STL, and this is gonna be ball joint, let's say tutorial. When exporting, make sure the density, which might be by default around 0.5, is all the way up to 1. Hit OK, and then I'm going to do the same for this one. I'm going to do Control-Shift-E, and I'm going to call that ball joint socket. Cut. Again, set the density to 1. Now I'm going to hop to Bamboo Studio. You can use anything for this, obviously, whatever slicer you want. I just found Bamboo Studio to be pretty convenient. I'm going to import my joints. I do not want to load this as one object with multiple parts. Let me move this away. And you can see by orienting them in plasticity, we already have them nicely aligned. As I said, if you want, you can print this facing up, but I really, really don't recommend it. So in this case, you would have the whole ball. You would just need to make this neck considerably thicker. Do consider that if you do that, the range of motion is going to be limited. I chose something like this because I know that if I print it facing down on the bed like so, it is not going to snap very easily. So as I said before, I'm going to use PETG for this, PETG, because I do prefer PETG. I'm one of those people. It doesn't really matter what you use for the ball, but you do want a flexible material, so either PETG or ABS for the socket. If you use PLA for this, it's still going to work. It's going to be very hard to push in, and it's not going to last very long. As I look at this, I think I might have wanted to make this a little deeper, but it's always something you can do. Do notice, though, that because plasticity is not parametric, if you don't keep a copy, you're going to have to manually remove all of these chamfers. I still think plasticity is really fast, so I don't mind the extra step that I have to do if I need to change something. So I usually just chamfer at the very end and keep a copy like this, just in case. So I'm going to slice the plate, making sure PETG is selected as material. I'm going to use a standard 0.2 millimeter layer height. Before hitting print plate, I'm also going to make sure that the bottom part of the sphere is touching the print bed. You can see we got a flat side here, we got a flat side here. We got some bridges here, but they're short enough that it shouldn't be a problem. And the socket is also aligned. Print plate, and it's all done. If you find that the joint is still too loose after printing, you can try to reduce the layer height to something like 0.16 millimeters. You can increase the wall loops to 3 or 4 to increase the overall rigidity of the joint, or make the socket slightly smaller than the ball, something like 0.05 millimeters less. If you enjoyed the video, like and subscribe. As always, thanks for watching, and I will see you next time.